Hello, in this video I would like to talk about how we can determine the end behavior of a polynomial function. So let's remind ourselves that a polynomial function has domain that is a set of all real numbers, no exclusion, but range, it depends on the type of polynomial function and its behavior. So make sure that you recognize polynomial functions. They are usually smooth and continuous. If function has sharp angles like here, it's not a polynomial function. If function is not continuous, which means has breaks or holes like here, this function is not a polynomial. Only one function among all these four is a polynomial function, is this one. So next step, we look at the polynomial functions, and we look at this certain subclass of polynomial functions which we power functions. So when the only one term is present, so we have a coefficient a, it's a number in front of a power of x. So if n is even, like n equals 2, 4, 6, 8, and so on, the graph of a function looks similar. They kind of either open upward if the leading coefficient a is positive, or open downward if the leading coefficient is negative. And both ends of the graph on the left hand side, right hand side, either going in the same direction, either upward for a positive or downward. Now, if n is positive integer but an odd number, like 1, 3, 5, 7, and so on, then the shapes of the power functions will be similar to the shape of y equals x cubed, and that's what you can see here. So it goes down on the left hand side and goes up on the right hand side. So we'll use these two examples to determine the end behavior of a function which we call power. So let's get used to some notation that is common for calculus class. You can introduce yourself here to this basic idea. So we say that x, then arrow means approaches infinity. That means that x becomes infinitely large in a positive direction. So if we have here the number line, and we have positive direction, and here we have negative direction, and to show the fact that x approaches infinity, so x growing in this direction, so x going this way. So that's how we use. And x approaches negative direction, negative infinity, that means x goes in negative direction. It becomes infinitely small, as you know, as larger number in absolute value, but with negative sign it's small. So it kind of, we're talking about numbers like negative 100,000 or even smaller. So that's why we use symbol of infinity in calculus, because we don't know what is the smallest number. We don't know what is the largest number. For that we use this abstract symbol of infinity. And also we say that f of x approaches positive infinity. F of x we associate with the y coordinate. So we're going to say f of x approaches positive infinity when the values of function go up and become very large. And f of x approaches negative infinity when the values of y become very small. Again, in this case, they are large in absolute value, but with a negative sign. And here again, we refresh on a definition of polynomial function. The general form of a polynomial function is f of x equals to a polynomial. As you remember, for an expression to be polynomial, all degrees must be integers, no fractions. And degrees means no square root for x or variable, whatever variable you use in that function. You can have square roots for the coefficients, but like square root of 2 times x is normal to have for polynomial function, but 2 root of x is not, because this degree is 1/2. And when we're dealing with polynomial function, so this is not a polynomial function part of a polynomial function, because when we're dealing with a polynomial function, all these powers must be only integers. So we need to write down a polynomial function in descending order from highest to lowest degree, and that's what we can look later at the leading term and its exponent. That's important. So to determine their end behavior, how function will behave when x approaches positive infinity or x approaches negative infinity, we need to analyze only the leading term. And in this case, we need to look at the sign of the leading coefficient and their degree. Let's look at this example. H of x equals 12x to the 5th, 8x to the 4th, negative 4x cubed, minus 8x plus 1. So we'll check that all terms in the right order from highest degree x to the 5th to the lowest degree, which is constant or degree of 0. So now we're ready to talk about the end behavior. So the leading coefficient a is positive, it's 12, and the degree, the highest degree, the degree of a polynomial is 5, odd number. So what do we remember from previous slide? We remember that the function h of x will behave at the end as function y equals x to degree 3 or x cubed, cubic function. So that's what is the end behavior. So the function will go down on the left hand side and go up on the right hand side. Now let's look at this function. So the function g of x. Again, we check that all terms in descending order. And now we're looking at the leading coefficient and the highest power of this polynomial. So you can see leading coefficient in this case is negative 1/2. So negative 1/2 leading coefficient, and highest degree is 6, even number. So the end behavior of this graph will resemble y equals x squared, but not with the coefficient 1, but with the coefficient negative 1, which we call upside down parabola. So it will be down on the left hand side and down on the right hand side. In the middle it can have some different options, up and down. So that's how easy to determine the end behavior. So with this one a little bit harder, but we're still aiming for the highest degree, and the highest degree will be determined by the product of leading degrees here. So one of them, negative 5x to the 4th, when you cube 2 minus x cubed, remember 2 minus x cubed, the first leading term will be negative x cubed. So that's what we will multiply negative 5x to the 4th and 2x, which is, we don't need to do anything here. So what happens if you multiply these leading terms? You get negative by negative positive. You get 10x to degree 8, right? So positive 8 and degree is even. So the graph of this function at the x approaching negative infinity and x approaching positive infinity will resemble the graph of y equals x squared function or parabola when leading coefficient is 1. And when leading coefficient is 1, y equals x squared, the function, the graph of a function goes up on both ends. So the same happens for the x to degree 8. Thank you for your time.